So we use information about data in our size estimations. Once again, where do we get that data? As we mentioned earlier, we can use system catalog for information about tables, views, and indexes. In addition to information such as name and type of attributes, constraints, and this kind of basic information, we can find information such as number of tuples in a relation, number of blocks in a relation, size of a tuple in a relation, and number of tuples of the relation that fit into one block in the system catalog. These are the numbers we need in size estimations. It is worth to mention that these statistical information about the relations change in every update to the database. However, maintaining the updates in such a high frequency introduces a huge overhead to the database management system. Therefore, these statistics are not updated on each update to the database. In fact, many database management systems do not update them automatically at all, and they rely on the administrator to initiate the updates. Also, often, these statistics are computed from a sample of an underlying data. They do not examine the whole collection of data in the database and are based on a random sample. However, they can help improve the estimates with more detailed statistics. Estimates can be improved considerably by maintaining more detailed statistics than just the low and high values in the index. One of these useful statistics is the frequency of a value for an attribute in a relation. Assume, as we see in the graph A here, we have the distribution showing the number of times each value has happened for an attribute. This means it shows the number of tuples that have that value for their attribute. For example, value 0 has happened 2 times. In other words, we have 2 tuples with value 0 for the attribute we are monitoring. Using this distribution, if we have a selection, for example, with condition the attribute larger than 13, we know that that means only the value 14, which has 9 tuples. So we have a size estimate based on the actual number of tuples for this relation. However, the burden of keeping this value for each value of each attribute for our relations is quite high. Therefore, an approximation is often used. So, assume instead of graph A, we have what we see in graph B, which has an approximate number 3 resulted from dividing the total number of tuples to the number of different values for this attribute. Well, this helps because it provides a number in the ballpark, but it is not very accurate. So, how can we have more accurate approximation without the huge overhead? One solution we can use is to divide the value range into a small number of buckets and approximate the values in each bucket. This adds additional work for each bucket, but yields a better approximation. So the question becomes how to choose the buckets. There are 2 main ways we can do that. Divide the range to sub-ranges of equal size, as you can see in graph A, or divide it to sub-ranges with almost an equal number of tuples within them, as you can see in the graph B. We can change the representation we saw in the previous slide to represent each bucket with the sub-range the bucket covers and the number of tuples in each sub-range. These are called histograms. The one with sub-ranges of equal size is called equi-width, and the one with sub-ranges with almost equal number of tuples within each range is called equi-depth. A histogram is approximation of value distribution for each attribute of a relation. It is maintained by the database management system. A histogram, as we saw, can be an equi-width histogram. An equi-width histogram divides the range of values into equal-sized subranges. It can also be an equi-depth histogram. An equi-depth histogram adjusts the boundaries of the ranges such that each range has almost equal number of tuples within. Equi-depth histograms maintain better estimates than equi-width histograms and are more popular with database management systems because of the same reason. Another type of histograms also used by database management systems are called compressed histograms. The special property about compressed histograms is that they maintain separate counts for a small number of very frequent values. This provides better estimates for those frequent values.